divide, I did not bring it to, or if I mean both of them are the same, because if I cancel, I use a different color. Okay, so if this is 1, okay, this is 3, right? So it's the same. And the shear force equation, like what you can see over here, is also exactly the same. Okay, they're exactly the same, as you can see. Okay, now after using the superpositioning, now you all can see the similarities, yes or no? Okay, right. So like what I mentioned before earlier, if we were to change our boundary condition, right? If we were to change our boundary condition, like simply supported, the entire expression will change. Okay, the entire expression will change. So let's do it now. Okay, some of you are curious. Okay, or I'm curious also. So now we know that this self equation are for cantilever, right? So what if now, okay, what if now is for simply supported? Okay, so same loading condition, everything the same. Okay, everything the same. So now we put in a condition that's simply supported. So simply supported, right? So as I said, the loading condition is exactly the same. And we have already formed the equation already. So X, so this is 6,000, 18,000, right? And now both of them are simply supported. So this is 6 meters. So X is equal to 0, X is equal to 6, V M theta Y, V M theta Y. So we know that moment is equal to 0. Another thing that we know is the deflection is also equal to 0. But the deflection is no use to us, okay? for now, okay? Not forever, for now. So we know the expression where we have omega as a function of x. So we know that we already done this, right? The equation is exactly the same. Only thing that changed is the what? Boundary condition. Okay? Boundary condition. So from here, we just write down dv over dx is equal to minus omega is a function of x minus 2,000 x minus 6,000. Right? Then we integrate v as a function of x. So this is equal to minus 2,000 x squared over 2 minus by 6,000 x plus by C1. Equation number 1. We have no boundary condition. That's why I want to show you this. Okay, so we have no boundary condition. So when you have no boundary condition, we move on. Okay, so no, don't like no boundary condition. I don't know what to do now, right? Okay. Anyone,
Professor,
any question? Yes.
for that minus sign in front of omega, is it kind of rule or it can be
Yes, it's
changed?
the root formula. You cannot change. As I said, I don't
Okay.
want to spend 15 minutes to derive it. You have to obey this rule.
Okay, thank you.
Okay. And as I said, it's not difficult to prove it out. It's really straightforward, but you just need to draw an element and free body diagrams. That's it. Okay. So now m as a function of x now. So it's equal to minus 2,000. You integrate again. Okay, I need to write this. So this is also equal to dm by dx. Okay. So this is s cubed over 6 minus by 6,000 x squared over 2 plus by C1x, now plus by what? C2. So now you have two unknowns, but thank God we have what? Two boundary conditions. So it is solvable. Okay. So you go and substitute when x is equal to 0, moment is equal to 0, right? So when that's the case, into equation 2, right? So you realize that, so this is 0 equal to minus 0 plus by C10 plus by C2, right? So C10 is also equal to what? 0. So therefore, from here, C2 is equal to 0. Okay. So you write out again. So M as a function of X is equal to minus 2000 X cubed over 6 minus by 6000 X squared over 2 plus by C2. It evolved from equation 2, so that's why it's called 2A. Okay. So now everything's still, if you look at this expression, right, everything is still good. Okay, still the same like the previous one, right, in terms of moment, right? The previous one, what did we have? The previous one is minus 2000. The previous one at this stage is equal to what? Minus 2000 x cubed over 6 minus 6000 x squared over 2, right? So it's still the same, except we have a what? We have a C2 now, right? So when we have a C2, so next we're going to substitute X is equal to 6, M is equal to 0 into now equation, okay, equation 2A.
Sorry, Eugene. Can you explain
Yes.
again to 2A again? Why C2 over there?
Oh, wait. Yeah, C2 is equal to 0. Very good, very good. You're not sleeping in Korea, yeah? He's in Korea and he's what time is it over there? 10:30 or 11:30?
11:30
Yeah,
p.m.
11:30 p.m. Okay, I just woken up. Okay, I like that. Okay, my computer is slowing down. So from here,
Eugene,
yes.
um, shouldn't it will be C1X though?
Huh? Oh yeah, yeah. Okay, I need you to do me a favor. Okay, I thank you for correcting me. I really appreciate. Remember the amount of beer that I owe you. Okay, I feel so bad now. Okay, so over here, so you substitute equal to minus 0 is equal to 2000. So minus 2000 6 cubed minus 2000 times by 6 power 3 divided by 6. So it's equal to minus 72,000. And then minus by 6,000 times by 6 squared divided by 2 minus by 108. 1, 2, 3. Okay, plus by 6C1. Okay, so therefore, so 72,108 plus by 72 is equal, yeah, 180. So you bring over is plus or equal to 6C1. So C1 is equal to 30,000. So finally, your moment equation is equal to minus 2000 x cubed over 6 minus by 6,000 x squared over 2, right? Then plus by 30,000 x. Okay. So this is our equation 2b because it evolved from equation 2. So now you can see, right, how the purpose of this exercise is I want to show you, okay, so sorry, so we still have to write out v as a function of x is equal to minus 2000, okay, x squared over 2 minus by 6,000 x, okay, plus by C1 30, okay, times 10 to the power 3. Is C1 30? Yep. Okay, C1 is equal to, wait, I'm having some, yeah, so equal to minus plus, okay, so this is our equation 1a. Now question, which equation can we check to make sure that the moment equation is right? How do we know that the moment equation is right? Anyone? Which one can we, what can we do to check? Anyone?
Differentiate it.
Yeah, differentiate is the obvious one. What's another way of checking?
Put in the boundary conditions.
Yeah. So if you substitute, no point substituting this equation when x is equal to 0, right? When x is equal to 0, all is equal to 0, so nothing to check. The better check is x is equal to what? 6, right? So when we substitute m and now 6, so this will become what? Minus 2000 times by 6 power of 3 divided by 6. So this is equal to minus 72,000. And then minus about 6,000 times 6 squared divided by 2 minus 108. And then the final one is plus by 2,000, 30,000 times 6 is equal to 180. So when you do everything, so minus 72,000 minus 108,000 plus 180,000, this is equal to 0. So this is correct. As I said, a good engineer, okay, which I want you all to be, is able to check whether the answer is right or wrong. Okay, most important, not anything else. In that case, let's take a break. Okay, we stop here. Come back at 10:45. Okay, as I said, this topic is nothing but a lot of integration and or forming boundary condition. Okay, so we take a break. We come back at 10:45. Thank you.